Okay, first of all, you should be very impressed because in order to make this work, I have to write upside down. So you're probably familiar with a formula that says area equals length times width. That tells you the area of a rectangle. So for example, in this rectangle here, the length is 4 inches and the width is 3 inches. Therefore, its area is 3 times 4, which is 12 square inches. And what that means is that 12 square inches would fit inside that rectangle. So taking that information into account, remembering that area equals length times width, the area of this tiny little piece of paper, which is 1 inch by 1 inch, is 1 square inch. So that's 1 square inch. This one, I didn't measure it all with a ruler. I just kind of cut it out as long as I wanted. So I don't know the length and the width. Since I don't know, I called it x. X times x is x squared. So we can't really say it's a number, but we can say it's whatever this number is squared. So we'll say the area of that square is x squared. This little rectangle is 1 inch wide, measured that with my ruler, and x long, which is however long I made that one, which was just arbitrary. So length times width is 1 times x, which is x. So I have these little pieces of paper here, each of them with a different area. An area of 1, an area of x squared, an area of x. So what I'm going to do is I'm going to give you a bunch of these pieces of paper. I'm going to give you some x squareds. I'm giving you 2 of them. 1, 2. I'm going to give you 5 of these x's and 3 of these little ones. Here they are. And what I want you to do is to create a rectangle using all these pieces. Because then, by looking at the rectangle, I can tell you what its length and width is. So I'll always start off with the x squareds. So I'm going to put these together like this. And then I'm going to try to build a rectangle around this, starting with the x's. Let's see, I can put that one there, and that one there. That lines up pretty well. And let's see, what else could I do? Maybe one here, and one here. I've got this leftover one, so that doesn't look very good over there. Maybe it would look better over here. Then I have this little one and this little one, but I still have this one left over, so let me try to rearrange this a different way. Let's see, maybe I can put these over here. Oh, that looks pretty good. Now I can have 1, 2, and 3 here. So the area of this rectangle is 2x squareds plus 1, 2, 3, 4, 5 x's plus 3. Now let's find out what its length and width are. Let's see how wide it is from here to here. It is x plus 1. Let's see how far it is from here to here. I should probably put little lines there. Well, over here I have x and x. I can tell because it's x and x down there. So x and x, that's 2 x's. As far as the length is concerned, I'm not talking about the area. And the length here is 1, 2, 3. And because we know that area equals length times width, we know that 2x squared plus 5x plus 3 equals the length, which we found out to be 2x plus 3, times the width, which we found to be x plus 1. Ta-da! That's how you can show factoring in a physical way.